Hi everyone. In this video, we will use the empirical rule for normal distributions to estimate probability. A normal distribution is observed from the times to solve a puzzle. The mean is 15 minutes and the standard deviation is 3 minutes. Using the empirical rule, what is the probability that a randomly selected solving time is less than 24 minutes? We were told that this was normally distributed, so let's draw ourselves a normal curve. And it should be symmetric on both sides. And right down the center, where you can fold it, is where we have our mean or mu. We were even told this. The mean is 15, so we could label that on our curve as 15. A normal curve has most of its data between 3 standard deviations of the mean, and they fall approximately like that. We can even label that as 1 standard deviation above the mean, 2 standard deviations above the mean, and 3 standard deviations above. The same goes on the left, but it is 1 standard deviation below, 2 standard deviations below, and 3 standard deviations below. Using that, we could go ahead and add our standard deviation of 3 minutes to our mean to label the rest of our curve. Let's go ahead and we will add 1 standard deviation of 3, so we will add 3 here, which makes this 18. Adding 3 more makes this one 21, and adding 3 more makes this one 24 minutes. Now on the left side, we will subtract the standard deviation of 3 minutes, making 15 minus 3 is 12, minus 3 more is 9, and minus 3 more is 6. Because this follows a normal distribution, we have the empirical rule that gives us an estimate about how much data falls between 1, 2, and 3 standard deviations of the mean. Within 1 standard deviation of the mean, approximately 68% of the data will fall. Within 2 standard deviations of the mean, approximately 95% of the data will fall, and within 3 standard deviations of the mean, approximately 99.7% of the data will fall. Now, because 99.7% is within 3 standard deviations and the entire probability needs to be 100%, let's go ahead and figure out how much will be left over on the outsides of here and here. So we will take 100 and subtract the 99.7. 100 minus 99.7 gives us 0.3. So we have 0.3% for the tail ends of our curve. But that's needing to be divided amongst both ends, above and below the 3 standard deviations outside. So we need to take that 0.3 and divide it by 2, and that will give us 0.15. So this over here is approximately 0.15% of the data, and over here, below 3 standard deviations, is approximately 0.15% of the data. Now let's go read the last part of our question. It asks for the probability that a randomly selected solving time is less than 24 minutes. Looking at our normal curve, we see 24 minutes is at the very topmost 3 standard deviations above the mean. And we want to know how much is below that. So we want to find, let's shade it in so we see everything. We want everything below the 24-minute mark, everything this way. We know between the standard deviations, the 3 standard deviations, that we will have 99.7% of the data. However, we're now including our small tail end that we found is 0.15%. So let's go ahead and add that as well. So we have 0.15%. Adding those together gives us 99.85%. Now that's the percent, and we were asked to find the probability. So let's go ahead and change this from the percent to the decimal, 0.9985. We've now found the probability that a randomly selected solving time is less than 24 minutes, and we're all done.